Let's take a look at this example. The question is, what is the ohmmeter reading for the following conditions? Okay, so let's look at the condition A. S1 is open. Okay, S1 is open. S2 is open. And S3 is open. Please notice that if S1 is open, it doesn't matter what happened with these two switches, okay? Because if S1 is open, there is no current flowing through the rest of the circuit beside this resistor, okay? So simply we don't look at these resistors and these switches anymore, and we simply concentrate on resistor R1. So when S1 is open, S2 is open, and S3 is open, total resistance RT in this case is going to be equal R1, because current is going to flow only by resistor R1, okay? And this is equal 3.3 kilohms. Okay, so this is the answer for part A. Part B. S1 is open, okay, S2 is closed, and S3 is closed. As I said before, when S1 is open, okay, there is no current flowing to this section of the circuit. So it means that no matter what happened over here, this is not going to affect the total resistance, because this switch is open. Current is not flowing further than by this resistor. Okay, so again, for part B, R total is equal R1, and this is equal 3.3 kilohms. Okay, section C. S1 is closed, S2 is open, okay, S2 is open, and S3 is closed. Okay, so switch 1 is closed, switch 2 is open. So when switch 2 is open, no matter what happened in this section, okay, this is not going to affect the reading of my ohmmeter. Okay, so I'm going to concentrate only on these two resistors, okay, because switch 1 is closed. When switch 1 is closed, so my current is going to split into two currents. I'm going to have I1 and I'm going to have I2. So simply the total resistance is going to be calculated this way. R total, I'm talking about this section C. This is C. Alright, so I have R total is equal R1 times R2 over R1 plus R2. R1 is equal 3.3 kiloohms times 4.7 kiloohms over 3.3 kiloohms plus 4.7 kiloohms. Okay, I'm going to use the calculator. So I have, let me put like this, okay, so everybody can see. So I have 3.3 exp 3 times 4.7 exp 3 divided by, open parenthesis, 3.3 exponent 3 plus 4.7 exponent 3, close parenthesis, equals, this is equal 1.93, I can say 94 kiloohms. Okay, So when switch 1 is closed and switch 2 is open, the total resistance is going to be the resistance of these two resistors together, and this is equal 1.94 kilo ohms. Again, please notice that the total resistance of these two resistors, which are connected in parallel, okay, is less than the value of the lowest resistance in this circuit. Okay, so I'm talking only about these two resistors, these two. So we got value 1.94 kilo ohms. So it means that our answer is correct. Okay. So next, we're supposed to go to part D. S1 and S2 are closed. S1 is closed, S2 is closed, and S3 is open. Okay, so when S1 is closed and S2 is closed, means we have to calculate the total resistance of these three resistors because they are connected together. Okay, S3 is open, that's why we don't care about this part of the circuit. So we have R total is equal 1 over, and I have 1 over R1 plus 1 over R2 plus 1 over R3. Okay, so I have 1 divided by, open parenthesis, 1 divided by R1 is equal 3.3k plus 1 divided by 4.7k plus 1 divided by 6.2k. Okay, now I'm going to use the calculator. So I have 1 divided by, open parenthesis, 1 divided by 3.3, okay, exponent exp3, plus 1 divided by 4.7 exp3 plus 1 divided by 6.2 exp3. Close parenthesis, this is equal 1.47 kilo ohms. And again, we are dealing with the parallel circuit. We have three resistors in parallel. The total resistance of these three resistors, okay, of course these two switches are closed, is less than the lowest resistance in the circuit. Lowest resistance in the circuit is 3.3 kilo ohms. So it looks that we are doing fine so far. Now, part E. S1, S2, and S3 are closed, means all switches are closed. Okay, so if you are going to close these switches, okay, switches and this one, we are going to get to this section. Okay, please notice that in this section we have no resistor. We have just piece of wire which simply connects, the positive terminal of my ohmmeter, right, with the negative, okay, directly. Okay, and keep in mind that the current is very lazy guy, and if there is opportunity for it to just avoid any resistance, current is going to always choose the easiest path to reach the ground. So if there is no resistance over here, okay, this is like closed door, closed door, closed door, and this is open door. So current is going to take open door in order to reach the negative terminal of the ohmmeter. So it's going to completely ignore these resistors and simply go by this. So your ohmmeter is going to measure 0 ohms. Okay, it means that the circuit is short. Okay, the circuit is short. So these are the solutions for this scenarios.